Welcome to G Fun Facts Online. In the cold, vast darkness of the outer solar system, where the sun is merely a piercingly bright star, there exists a world that defies the icy logic of its neighbors. It is a world of fire, brimstone, and unceasing violence, a celestial body that looks less like a moon and more like a pizza left too long in the oven, mottled with sickly yellows, vibrant reds, and bruised blacks. This is Io, Jupiter's innermost Galilean moon, the most volcanically active body in our solar system. For decades, we have known of Io's torment. We have watched its volcanoes paint the void with plumes of sulfur reaching hundreds of kilometers into space. But just when we thought we had mapped the chaos of this tortured world, Io has surprised us again. Earlier this year, amidst the data beamed back from NASA's Juno spacecraft, scientists uncovered something unprecedented, a new, monstrous volcano. A fire on the moon so vast and energetic that it rewrites our understanding of planetary geology. This is the story of that discovery, the detection of Io's newest and most terrifying feature, and what it tells us about the violent heart of the Jupiter system. The discovery did not happen with a bang, but with a stream of binary code traveling 600 million kilometers through the vacuum of space. It was late 2024 when NASA's Juno probe, originally designed to peer through Jupiter's dense clouds, swung its gaze toward the fiery moon next door. Juno's extended mission had transformed the spacecraft into a daring explorer of the Jovian moons, and its encounters with Io were becoming increasingly daring. On December 27, 2024, Juno executed its 66th parallel, or close flyby of Jupiter, skimming just 46,200 miles, or about 74,400 kilometers from Io's surface. While its camera, JunoCam, snapped visible light images that would later dazzle the public, it was the Jovian infrared auroral mapper, known as JIRAM, that saw the true heat of the beast. As the data was processed in early 2025, the team at the National Institute for Astrophysics in Rome noticed an anomaly. In the southern hemisphere, a region previously mapped as relatively quiet by Io's extreme standards was screaming in the infrared spectrum. It was saturated. The detector was completely overwhelmed. When the team calibrated the data, they realized they were not looking at a standard eruption. They had found a brand new volcanic hotspot, a churning lake of lava covering an area of approximately 40,000 square miles. To put that into perspective, this new feature is larger than Lake Superior, the largest freshwater lake on Earth by surface area. But it was not just the size, it was the power. The thermal emission from this single region was calculated to be over 80 trillion watts. In more visceral terms, this one volcano was emitting 6 times the energy produced by every power plant on Earth combined. It was, as principal investigator Scott Bolton put it, the most powerful volcanic event ever recorded on the most volcanic world in our solar system. They had found a monster, a new eye of fire staring back from the dark. To understand why this discovery is so significant, one must first understand the tragedy of Io's existence. In a solar system where most moons are geologically dead craters of ice and rock, Io is a zombie that refuses to stop moving. Io's torture is a result of a cosmic tug-of-war. It orbits Jupiter, a gas giant with 318 times the mass of Earth. But it is not alone. It is in a rhythmic orbital resonance with its sibling moons, Europa and Ganymede. For every 4 orbits Io makes, Europa makes 2, and Ganymede makes 1. This precise gravitational dance forces Io into an eccentric, elliptical orbit. As it swings close to Jupiter, the planet's immense gravity stretches the moon into a rugby ball shape. As it swings further away, the moon bounces back to a sphere. This constant stretching and squeezing, known as tidal flexing, creates friction deep inside Io's rock. Imagine bending a metal spoon back and forth rapidly. You will feel the metal get hot at the bend. Now, imagine that spoon is a moon the size of our own, and the hand bending it is the gravity of the largest planet in the solar system. The result is enough heat to melt rock, turning Io's interior into a slush of magma that must escape. The new volcano discovered by Juno is the latest pressure valve to burst open in this global machine, but its location and intensity suggest that our models of Io's interior might be too simple. For years, scientists debated whether Io had a global magma ocean beneath its crust or a sponge-like mantle filled with interconnected pockets of melt. The sheer scale of this new eruption and the fact that it appeared in a region not previously dominated by such massive activity points toward a vast, highly mobile subsurface reservoir that can mobilize colossal amounts of lava on short timescales. While the massive southern hotspot dominated the headlines in early 2025, it was not the only new volcano Juno found. In fact, the mission has revealed that Io is even more dynamic than previously thought, capable of birthing complex geological features in the blink of a cosmic eye. Months prior to the southern hotspot announcement, researchers analyzing JunoCam images from early 2024 spotted another anomaly near Io's equator, just east of the known volcano Kanehekili. When they compared these images to those taken by the Galileo spacecraft in 1997, they were stunned. In the 1997 images, the region was a featureless, flat plain. In 2024, it was home to a sprawling volcanic complex covering nearly 12,000 square miles. Towering red deposits of sulfur fan out from a central vent, and two massive lava flows, each stretching over 100 kilometers, scar the landscape. This large, complicated volcanic feature appeared to have formed from nothing since 1997. In geological terms, 27 years is less than a nanosecond. On Earth, building a shield volcano like Mauna Loa takes hundreds of thousands of years. On Io, mountains of fire can rise in the span of a human career. This equatorial discovery, combined with the massive southern hotspot, paints a picture of a world that is constantly resurfacing itself. Io is turning itself inside out, burying its past under layers of fresh lava so quickly that impact craters, the standard clock for dating planetary surfaces, are virtually non-existent. What is this new volcano made of? If you were to stand on the rim of this newly discovered caldera, wearing a suit that could withstand radiation capable of killing a human in minutes, what would you see? Unlike Earth's volcanoes, which spew silicate lava, water vapor, and carbon dioxide, Io's eruptions are a toxic brew dominated by sulfur. The red stains seen around the new equatorial volcano are likely short-chain sulfur allotropes. Sulfur, a shapeshifter of an element, changes color depending on its temperature and molecular structure. Pure molten sulfur is black at its hottest, turning red, then orange, and finally yellow as it cools and solidifies. The iconic pizza coloring of Io is essentially a temperature map of sulfur fallout. However, the lava flows themselves, the rivers of fire pouring from the new southern hotspot, are likely not just sulfur, they are too hot. The temperatures measured by JIRAM, often exceeding 1,300 degrees Celsius, indicate that the bulk of the flow is ultramafic silicate lava. This is a primitive iron and magnesium-rich magma similar to what erupted on Earth billions of years ago during the Komatiite era, when our planet was much hotter. Io is a time machine. It shows us what the early Earth might have looked like, a magma ocean world with a thin, unstable crust venting its heat directly into space. The new discovery provides a fresh laboratory to study these high-temperature lavas, which are extinct on modern Earth. The discovery of this new volcano is the latest chapter in a 400-year saga of exploration. When Galileo Galilei first pointed his telescope at Jupiter in 1610, he saw 4 stars dancing around it. He had no idea that the innermost one, Io, was a hellscape. To him, it was a point of light that proved not everything orbited the Earth. For centuries, we assumed Io was a cold, dead rock, like our moon. That illusion was shattered in March 1979. As Voyager 1 flew past Jupiter, navigation engineer Linda Morabito noticed a faint, umbrella-shaped smudge on the limb of Io in a navigation image. It wasn't a moon behind Io. It was a plume. The volcano Pele was erupting, shooting material 300 kilometers high. It was the first time active volcanism had been seen on another world. Between 1995 and 2003, the Galileo spacecraft orbited Jupiter for 8 years, providing us with our first long-term monitoring of Io. It watched volcanoes turn on and off, saw the surface change color, and mapped the major paterae, or volcanic depressions. It was Galileo that imaged the empty plain, where Juno would later find a new volcano. Then in 2007, en route to Pluto, New Horizons swung by Jupiter for a gravity assist. It captured one of the most famous movies in space history, the Tvashtar volcano erupting, its blue plume silhouetted against the black of space, with the filamentary structure of the ejecta clearly visible. Today, we are in the Juno revolution. Juno was never meant to be an Io mission. It is a polar orbiter designed to study Jupiter's gravity and magnetic fields, but as its primary mission ended and its orbit evolved, NASA engineers realized they could use the probe to perform daring flybys of the moons. The discovery of the fire on the moon in late 2024 is the crown jewel of this extended mission, proving that old spacecraft can still learn new tricks. Why does a new volcano on a dead, poisonous moon matter to us? The answer lies in the search for life, not on Io, but elsewhere. Io represents the extreme end of tidal heating, but a milder version of this same process keeps the subsurface ocean of Europa liquid. Europa, the moon next door, is an ice world with a global ocean containing twice the water of Earth. If tidal heating can melt rock on Io, it can certainly keep water liquid on Europa. The new volcano on Io helps us calibrate our models of tidal dissipation. By measuring exactly how much heat Io is releasing, and this new hotspot suggests we may have underestimated the total heat flow, we can better estimate the energy budget of Europa. If Io is hotter than we thought, Europa's ocean floor might be more geologically active than we dared hope, potentially hosting hydrothermal vents, the same environments where life may have begun on Earth. Furthermore, this discovery impacts the study of exoplanets. We have found many super-Earths and sub-Neptunes orbiting close to their stars, likely subject to extreme tidal forces. Io is our only local example of a tidal world. Understanding how Io sheds its heat through massive sporadic eruptions like the one Juno just found helps us interpret the signals we might one day see from magma worlds orbiting other stars. As 2025 draws to a close, the Juno mission is entering its twilight. The radiation environment near Jupiter is punishing, frying electronics and darkening solar panels. But the data from the December 2024 flyby will be analyzed for years. Scientists are currently working to name the new feature. Following the International Astronomical Union conventions, it will likely be named after a fire, sun, or thunder deity from world mythology. Perhaps it will be Agni Patera, Hephaestus Patera, or something drawn from a culture not yet represented on Io's map. But the exploration of Io is far from over. The discovery of such massive, transient volcanism has bolstered the case for a dedicated Io mission. The Io Volcano Observer, a proposed NASA mission, would orbit Jupiter and perform multiple flybys of Io, specifically to monitor these eruptions. It would fly through the plumes, tasting the chemicals directly to see if they contain clues about the primordial solar nebula. Until then, we watch from afar. The discovery of Io's newest volcano is a reminder that the solar system is not a static museum of rocks. It is dynamic, evolving, and often violent. Fire on the moon is more than just a headline. It is a reality of our cosmic neighborhood. In the time it took you to listen to this podcast, the new volcano on Io has likely spewed thousands of tons of lava onto the surface. The landscape has changed. The map is already outdated. Io serves as a humble counterpoint to the pale blue dot. It is the angry yellow eye, a world that screams into the void, powered by the gravity of a giant. And thanks to the robotic explorers we send into the dark, we can hear it. As we look up at Jupiter in the night sky, appearing as a steady white light, we now know that circling it is a world of fire, burning brighter than ever before, a testament to the raw, creative, and destructive power of the cosmos. Thanks for listening to G Fun Facts Online.